Hi, today our topic is energy flow in an ecosystem. Energy flow in an ecosystem is unidirectional, or we can say energy flow in an ecosystem is one directional or non-cyclic. So it is unidirectional, one directional or non-cyclic. Or non-cyclic. These producers, herbivores, carnivores, and besides these decomposers, they are the main component. They are the components of the ecosystem. We will discuss producers, herbivores, and carnivores. We will use these to understand the concept of energy flow in an ecosystem. Sun, it is prime source of energy. It is prime source of energy for the ecosystem. We are getting solar energy from the sun. Solar energy. These plants, they are special because they have got the ability to convert solar energy into chemical energy. Chemical energy. These plants, the plants convert solar energy into chemical energy. 1% of energy. 1% of energy which falls on the producers is being converted into chemical energy. Out of all the energy which falls on the producers, just 1% of the energy is converted into chemical energy. Now look here. Producers, they are eaten up by herbivores. Herbivores are eaten up by carnivores. Producers, these events where one organism eats another organism and is eaten up by some other organism is called food chain. And each step of food chain is called trophic level. For example, this is one trophic level, this is other, first trophic level, second trophic level, third trophic level. This energy flow in an ecosystem, it follows some laws of thermodynamics. First law of thermodynamics, it follows. First law of thermodynamics says energy can neither be created nor destroyed, but it can be converted from one form to another form. See here, what these producers they are doing, they are converting one form of energy, which is solar energy, into chemical energy. Now these producers are mostly their plants. They possess chemical energy. When these producers they are eaten up by herbivores, some part of chemical energy it gets transferred into herbivores. Now these herbivores they are being eaten up by carnivores, and some amount of energy which is present in the herbivores it gets transferred into carnivores. So this energy flow, it is following first law of thermodynamics. First law of thermodynamics. It also follows second law of thermodynamics. What second law of thermodynamics says? It says whenever energy is transferred from one system to another system, some amount of energy is lost into the environment. Or we can say there is always loss of energy whenever energy is transferred from one system to another system. Look here, what energy is being transferred from producer to herbivore or from herbivore to carnivore. There is loss of energy. Some amount of energy is being lost into the environment. So this energy flow in an ecosystem, it also follows second law of thermodynamics. Now how much energy is being transferred and how much energy is lost into the environment. This is being said by this we can get by the 10% law. 10% law states that 10% of energy is being transferred from one trophic level to another trophic level, and rest, which is 90% of energy, is lost into the environment. So 10% law. It is also energy flow in an ecosystem. It also obeys 10% law. So it is not actually 10%. Typically it is 10%, but it can range from 2 to 40%. 2 to 40%. Typically, mostly it is 10%. So 10% of energy is transferred from producer to herbivore to carnivore. Now look here, producers, they have got maximum amount of energy. Carnivores, they have got less amount or least amount of energy out of these three. If human beings start eating producers, or if human beings are eating producers, the earth would be able to support maximum number of human beings. If we start eating a carnivores only, the earth would be able to support lesser number of human beings, because here the loss is maximum, here the loss is minimum. And besides this, what we can see, if we graphically represent these, the producers would be maximum in energy, followed by herbivores, primary consumers, followed by carnivores, secondary consumers. The graphic representation of this, the graphic representation of energy would be like this. So the pyramid of energy, which is graphic representation of energy present at different trophic levels in an ecosystem, it is upright pyramid, and it will always be upright pyramid. Why it will always be upright pyramid? Because these producers, they have got maximum amount of energy, and whenever energy is being transferred from producers to primary consumers, then from primary consumers to secondary consumers, there is loss of some amount of energy. So this, no matter what type of ecosystem we are studying, we will find this thing constant. This pyramid of energy, it will always be constant. Now listen, ocean ecosystems. In ocean ecosystem, the maximum amount of energy is being transferred via such type of food chain, while producers are being eaten up by primary consumers. They are eaten up by secondary consumers, because the decomposition is very less, or the organic matter which is left to die and decay, that is very less. So in ocean ecosystems, this such type of food chain which starts with producers is called grazing food chain. So most of the energy is being transferred in oceanic ecosystems via grazing food chain. Whereas in case of forest ecosystems, you will see a lot of litter is there, which degrades, which decomposes, which is being taken up by these detritus eating organisms. So maximum amount of energy is transferred in forest ecosystems via detritus food chain. I think that will be sufficient for today. Thank you.